Hello everyone, welcome back to your favorite and India's most affordable learning platform, Physics Wallah. So in the last session of circular motion, so we discussed about the centrifugal forces and especially how the turning of the car on different roads like level road and banked road, and then banking with friction, right? So, and we have derived some formulas and we solved some questions related to that. So, and we discussed about conical pendulum, death wheel or rotor or bending of the cyclist. So these are all the part of your circular motion. So now in continuation with the circular motion in lecture number 5 today, so we are going to start the motion in a vertical circle. So this is going to be the last topic of our circular motion. Okay, so after this I'll start the work energy power. Okay, so this part is going to be very important and some standard results you guys should remember. What are all those standard results you have to remember and how to remember them easily? So everything I'll discuss in today's session. Okay, so I just need your attention for next 1 hour. Be with me and avoid all the disturbances around you guys. And at the end of the class, it's very important to prepare your own short notes. Chalo. So with a very high positive energy, let's begin the today's session. So that is motion in a vertical circle. See, so first let me give you the introduction of this concept. So what does it mean by motion in a vertical circle? So consider, let's suppose here is a fixed end, some string is attached here. So and here is one mass is there. So then you gave some velocity to this one. You gave some velocity to this bob of mass m, and then so let's suppose it reached here. So it is not said to be complete vertical circle. So then again you gave some other velocity. So then what happens? So let's suppose it reached here. So again it's not a vertical circular motion. So you gave more velocity this time. So then what happens? So it completed the vertical circle. It started from here and then so it completed the vertical circle. Okay, so this is called the circle that made by it is called the vertical circular motion. So let me show you here. So for example, so this is a object. So if I give the velocity, enough velocity for this, see here, so not given enough velocity. So let's give the enough. So now this time also not given. So chalo. So previously I gave the enough velocity for that so that it completed its vertical circular motion. See, right, one complete revolution like that. So it's a vertical circular motion. So now here, what are the different questions that can be framed and what are the standard results that we should remember? So here, whatever the velocity that you are giving, let it be the point A, and at the point A the velocity be the VA. Let the velocity at this point A be VA. Okay, and then let this be, so this is point A and this is point B and this is point C. Okay, so this is a horizontal point here. Now, so what should be the tension at point A and what should be the tension at point B and what should be the tension at point C, and what is the minimum velocity that it should maintain at the topmost point so that it completes a vertical circular motion, and then what is the velocity at some random point P. Let's suppose if I take some random point P, so if the bob of mass m reached here, so what is the velocity at this point and what is the tension at this point and what is the velocity at this point and what is the velocity at this point and what is the velocity at this point, so that it completes a vertical circular motion. So these are all the standard results that we are going to calculate. So what is VA, what is VB, what is VC, and what is tension at A and what is tension at B, what is tension at C. Okay, so and what is the velocity at some random point P at any angle theta. So let's go for all these. Okay, chalo. So this is just the introduction. So now let's understand these concepts by solving the questions. Actually these are concepts only, but I am giving it as a question. Okay, chalo. So observe carefully guys. Find the velocity of particle at P in terms of VA, theta, R and G. See, so the particle is attached to some fixed end here, and then this is a string and it is attached to the string. So this is particle is of mass m. So let this be point A. At point A I am giving so some velocity VA. So and then the particle reached so some point P. So at point P let the particle velocity be VP. So the particle velocity. So now we have to find the particle velocity at point P. At this point, what is the velocity of the particle? So that we have to find. So for that, what I am doing is, let's do one thing. So for A and P, between A and P points, let's use a conservation of mechanical energy. Let's use the conservation of mechanical energy. You studied in the grade 9th. So the conservation of mechanical energy means, so the initial kinetic energy plus initial potential energy is equals to final kinetic energy plus final potential energy. So at which points we are applying it? At A and P points. So the potential energy at A plus the kinetic energy at A is equals to the potential energy at P plus the kinetic energy at P. Right? So now see here, initially, so consider, let's say this is the ground. Understand the procedure. So consider this as a ground. Consider this as a ground. So now see, the initial potential energy is 0, I can say. The initial potential energy is 0 because it is on the ground initially. So and then initial kinetic energy, it has given some velocity VA. So that initial kinetic energy will be half mv square. In place of V I am writing VA, which is equals to, so the final potential energy. So let's suppose, so the particle reached so vertically this much height. So this is a height which it is reached, right? From here to here means the vertical height is h, right? So that's why in place of this potential energy, so I am writing mgh, right? So final kinetic energy half into mass of the particle will not change. So and the velocity will become, so the velocity at point P Vp whole square, right? Chalo. So now let's do one thing. Let's calculate this one. Half mva square is equals to mgh. So let's take m comma gh. Sorry guys, gh plus half half Vp square, right? So then mass gets cancelled. So from here, so the velocity at which point we required, so the Va square is equals to, we can write, send this 2 to this side. So 2gh plus so Vp square. So that means, so the velocity at point P, so let's write it in the next slide. So the Va square is equals to 2gh plus Vp square, right? Yeah. So now, so we need the velocity at point P. So which is equals to velocity at point A whole square minus 2gh, right? So then the Vp, the velocity at point P, is equals to Va square minus 2gh, so under root. So this is under root. Clear? So Va square minus 2gh. So this is a formula. But in the question, see, in terms of Va, theta, R, G. So in terms of Va is fine, but R, G is also fine, but R is not there, theta is not there. See here, in terms of R and theta also it should be. Now let's do the basic maths calculations. See, so this from here to here, the radius is R, right? And this length also becomes R. Yes or no? So now, shall I say this whole thing is R, and then its horizontal, its vertical component this side, the R cos theta this side. So this is R, right? So and its theta is this side. So it's one of its component will be R cos theta. Yes or no? So from here to here it is R cos theta, and the whole length is R. So now the h will be equals to, I can say h is, so total R minus R cos theta. Total R, see, h is this one, right? So total R minus R cos theta. If you solve that, you will get h, right? So that's what I am doing. The h is equals to R minus r common you can take, so 1 minus cos theta. So now I am substituting in place of this. So here r is equals to, here r is equal, h is equals to r minus r into 1 minus cos theta. So substitute this in the above formula, so that the velocity at any general point P, so which is equals to VA square minus 2g, in place of h I am writing r into, so 1 minus cos theta. So this is a formula. So to find the velocity at any general point theta, so at any general point, so this P can be here, or this P can be here, or this P can be here. So at anywhere on the vertical circular motion, so if we have to find the velocity at some point, so at that point, so the velocity is equals to square root of VA square minus 2gr into 1 minus cos theta. You remember this formula. Okay. So this will be useful, guys. So this formula you guys should remember. Okay. So because you can save time while doing the questions. Done? Clear this part, the derivation part? Chalo. So let's move further. Next. So let's go for the next one. Find the tension in the string at point P in terms of mass VA, theta, R, G. So see here, again let's go for the question. Understand the procedure here. At point P we have to find the tension. See here, first thing is, so the particle VA velocity here, and then so it is moving from here to here, right? So let its velocity be VP. So here the tension will be equals to this side at point P, the tension will be equals to this side, right? And then, so shall I write, so this side the centrifugal force will act outward. So what is that centrifugal force? mv square, vp square by r. The velocity at that point is vp, that's why actually the centrifugal force is mv square by r, but at that point the velocity is vp, that's why I am writing mvp square by r. Clear? Understood, guys? And then, so there is one more force also that is acting. What is that? This is mg, right? So this is mg. So and this angle is going to be theta. Sorry, guys. This angle is going to be theta, because if it is theta, this is a corresponding angle theta. So that's why this side the mg cos theta will come. So now if you observe, the tension is balanced by mv square by r plus mg cos theta. So I am writing that here. So the tension at point P is balanced by m vp square by r, so plus mg cos theta, right? So now let's go for the procedure. We need in terms of m, in terms of va, and in terms of theta, and in terms of r, and in terms of g. So now what I am doing is m into, so in place of vp square, shall I write this one in terms of vp square? So shall I write va square minus 2gr into 1 minus cos theta? Yes or no? So in terms of, in place of this I am writing vp square, so the va square minus, so 2gr into 1 minus cos theta, right, by r, so plus mg cos theta, plus mg cos theta. So this point is clear, everyone? Chalo. So now t is equals to, so let's write this aside, m va square minus, so here also you can write 2gr into m into 1 minus cos theta. So let's write r separately for each term. So for this term and for this term. Okay, chalo. So plus mg cos theta, plus mg cos theta. So let's do one thing. So now, so t is equals to m va square by r minus, so here r cancel, so 2gm into 1 is 2gm, so then minus of minus plus, so which is 2 mg minus of minus plus cos theta, right? So plus mg cos theta, right? So then this whole thing will become, so I can write, so the tension at that point, so let me write it here. So mva square by r, so here minus 2 mg plus, so this is 2 mg cos theta plus mg cos theta, which is 3 mg cos theta, so plus 3 mg cos theta. So this is a tension at some random point P. So if you need tension at some random point P, so you can follow this procedure. Okay, so this is a formula, mva square by r minus 2 mg plus 3 mg cos theta. Done, everyone? So just have a look at that. Hope it is clear, the derivation part. Done? Chalo. So next, let's move further. So find if, so tension A, tension B, tension C. So TA is greater than TB is greater than TC, or TC is greater than TB is greater. So we have to find tension at 3 points in this question. See here. So here we have to find the tension at 3 points. See here. First thing is at point A. At point A, let's see. So shall I say that at point A the theta will be equals to 0. So just now we have seen the tension formula, which is mva square by r plus, so 3 mg cos theta minus 2 mg plus 3 mg cos theta minus 2 mg, right? So t is equals to m into, so what is the velocity at A? So let it be the velocity at A. So what we can write, the velocity at A, anything is given. So let it be, the velocity at A is mv by r, mv square by r. So plus 3 mg cos theta minus, here cos 0 is 1, so 3 mg minus 2 mg, right? So then, so the t is equals to here mv square by r plus mg. So let's do one thing. What is this v value? What is this v value we can write, guys? See here. So here at this point the tension will be this side, and then the mg value will be this side, the tension and mg. And outward force, what is the outward force that acts? So it's a mv square by r. Yes or no? If its velocity is v at that side, so the v this part will act. So then the t is equals to, shall I write, mv square by r plus mg. So the t is equals to mv square by r plus mg. So now what I am doing is, what is the velocity that we need, right? The velocity at point, so let's find the, see, this part is also not required. So let's find the velocity at point A. So the velocity at point A formula is, we know that the va square minus 2gr into 1 minus cos theta. Yes, so here theta is 0, so that's why, so this is going to be va square, so minus cos 0 is 1, so this is simply the va itself. The velocity at point A is va itself, so that's why simply write va. So the tension, okay, so let the tension be like this itself. So mv square by r plus mg. So let it be, no need to go further. So at point B, so let this be. So then at point B, so theta is equals to 0 at point B, guys. So that the tension will be equals to, so I can write there m, the velocity at B whole square by r plus 3 mg cos 90. Yes or no? 3 mg cos theta, which means cos 90. So minus 2 mg. So cos 90 is 0, so that this term will become 0. Yes or no? So then this is the velocity at B whole square by r minus 2 mg, right? So let it be this, okay. And at C, at point C, so you can see that, so I can write t is equals to m into, so the velocity at C is vc square by r. So this angle theta is going to be how much? So the theta is going to be 180 for at angle C. So that's why 3 mg into cos 180, so minus 2 mg, so which means mvc square by r. So this is cos 180 is minus 1, so minus 3 mg minus 2 mg, which is minus 5 mg. So this is the tension at C. So now they are asking us to find compare the tensions at A, B, C. So if you observe here, so the tension at A is this part plus mg. So here it is this part minus 2 mg. So here minus 5 mg is getting subtracted. So which means, so obviously the tension at A is more. For this term it is getting added. Here 2 mg is only getting subtracted. Here 5 mg is getting subtracted. So shall I say that the tension at A will be greater than tension at B, will be greater than tension at C simply. So this is tension at A greater than tension at B is greater than tension at B, C. So what are these tension values that we'll discuss in the today's class itself while the class progresses. Okay. So but just understand that at tension A, like at this point, at the lowest point, the tension will be more, and next at the point B, and the tension will be low at the topmost point. See, and the probability is that wherever the tension is more, so the string may likely break there, right? So if the tension is more means, so the string may break at that point while moving in a circular path, right? So that's why, see here, let's see the question so that you'll understand. So the question which was asked in NEET 2019, see the question. A mass m is attached to a thin wire and is drilled in a vertical circle. So the wire is most likely to break when, so see here, a mass is attached to a thin wire and drilled in a vertical circle. The wire is most likely to break. We know that if it is drilled in a vertical circle like this, and if here is a bob of mass m, so here let's suppose the tension at A, and let's suppose here the tension at B, and then at this point the tension at C, right? So now shall I say that obviously the tension at A is greater than tension at B is greater than tension at C, just now we derived. So and whenever the tension is more, there the string may break, right? So that's why the mass is at the, when the mass is at the lowest price, at the lowest point, guys. When the mass is at the lowest point, it is. Yes, chalo. So at the when it is at the lowest point, it may break. So option 1 is itself is a correct, right? So there are no highest point, no. Wire is horizontal, no. So inclined at an angle 60 degrees from vertical, no. So option A1 is a correct one. Clear? So fifth question. As shown in the figure, at point O, a mass is performing vertical circular motion. So the average velocity of the particle is increased. So then at which point the string will break? So the string will likely break at the bottommost point, at the lowest point. So at point B, option 2. Again direct question, right? Sure. So let's go for the next question. See, one end of a string of length 1 meter is tied to a bob of mass 0.5 kg. So it is drilled in a vertical circle with angular. Okay, first let's draw the diagram so that you'll understand better. Understand each statement. See, one end of a string of length L is tied to a mass of 0.5 kg. It is drilled in a vertical circle. See here. So here is a string and one end. So here is a mass 0.5 kg. Right? So from here it is drilled now. So vertical circle with angular velocity 4 radian per second. So it is rotated with some angular velocity omega. Now, so find the tension at the string when the body is at the lowermost point of its motion. See, this is the lowermost point. So the tension will act upside. And what are all the other forces? mg will act, and the centrifugal force, which is mv square by r actually. But here, as it is moving with angular velocity, let me take mr omega square. Both are same, right? So the tension is balanced by mr omega square plus its own weight mg. So now the tension is equals to, so let's take m common. So the radius is going to be, so r omega square plus g. So let's substitute the values now. So what is the mass? Mass is 0.5 kg. Let's take it as 1 by 2. So what is r? R is 1. So 1 into, so this is omega square 4 square plus g value, let's take it as 10. So that it comes out to be half into, so 16 plus 10, 26, right? So 16 plus 10, yeah. So this is 13. So therefore, so the tension is 13 newtons. So the tension is 13 newtons. Option 3 is the correct one. Done. Clear, guys? Sure. So let's move further. So the question number 7. So what's the question says? See here. The string of a pendulum is horizontal. The string of the pendulum is horizontal. So this is horizontal like this. So the mass of bob attached to it is mass m. So this mass is m. Okay. So now the string is released. So that means its velocity is 0. So the tension in the string in the lowest point is, see, if it is released, so then it comes this path. Yes or no? So then when it reaches this point, so what is its velocity? So let its velocity be, so the velocity at point A. So here the initial velocity is 0. Here the final velocity will be VA, right? So what is the velocity they are asking? So this is going to be, obviously, theta is equals to 90 degrees. Yes or no? Horizontal to lowest point. So the theta will be 90 degrees. What we need? The tension in the string at the lowest point. So the simple procedure, either you can apply the conservation of mechanical energy, or here the tension is upside, and when the bob of mass m comes here, so its weight is mg, and then it's mva square by r, right? So first let's find the what is the velocity at point A. Can we find the velocity at point A? Va square is equals to, this is the starting point now. So this is the starting point, let it be P. So that means Vp square minus 2gr into 1 minus cos theta. Yes or no? So that's why here the Va square we have to find. So the Vp square, so the velocity, initial velocity is 0. The velocity at point P is 0 initially. So minus 2gr. So what is the the 2gr, what is the r value? So it is horizontal, so the radius is given. What is the radius that is given? See here. So the string of the bob, the string of, okay, horizontal, the mass is attached to it. So okay, let the r be r. So here 1 minus cos 90 is 0. So let it be that part itself. So the Va is equals to square root of 2gr. Yes or no? So 2gr minus 2gr you are getting. See, I guess I wrote the formula wrong. So we need the velocity at A, right? So we know that the velocity at P is equals to square root of, so the velocity at A, or else let's apply the conservation of mechanical energy, guys, instead of this. So you can find it by this method also. Both the methods, if you want, I can do it. So shall we do both the methods? Okay, no issue. Let's do both the methods. So let's find velocity at point A first. So how do you find the velocity at point A? So this is the initial, and then so final. So which is nothing but the velocity at point P square. Let's write this way, is equals to square root of velocity at A square minus velocity at 2gr into 1 minus cos theta. Yes. So here cos theta is nothing but theta is 90. So this is Vp square is equals to square root of Va square minus 2gr, right? So then this part is going to be, this is not square, so yeah, so now fine. So now bring it to this side. So the Va square minus 2gr is equals to Vp square. So the velocity at P is what? 0, right? So the velocity at P, so therefore Va square is equals to, this velocity is 0, so 2gr. So from here the Va is equals to root 2gr. Yes, fine. So now we got the velocity at point A. So now at point A, so let's write the tension equation. So the tension T is equals to mg plus mva square by r. Yes or no? So the tension T is up. So then mg plus mva square by r. So we need the tension only, right? So the T is equals to mg plus, so m into, so what is the velocity at point A? Root 2gr whole square by r. So therefore T is equals to mg plus, so this is m into, so 2gr by r. So here r cancels, so T is equals to mg plus 2mg, which is 3 mg is the tension in the string. So option 3 is the correct one, guys. Clear? Option 3, which is 3 mg. Done? Clear? Check. So let's move further. See, you can solve this question by considering the conservation of mechanical energy also. So the initial energy at P, the kinetic energy at P plus potential energy at P is equals to kinetic energy at A plus potential energy at A. So in that way also you can solve this. So you try that method as a homework. Okay? Sure. So let's move further. So what's the question says here? So the next 8th question. A stone is tied to a string of length L and is reeled in a vertical circle with the other end of the string as a center. Okay, fine. So at a certain instant of time, the stone is at its lowest position and has a speed u. So at the lowest position, so its speed is u. So this is a bob of mass m. At its lowest position, its speed is u. Fine. So then the magnitude of change in velocity as it reaches the position where the string is horizontal. So the magnitude of, so it reaches horizontal means when it reaches here, so the bob of mass m, so if it reaches here, so let's suppose its velocity has become v. Its velocity has become v. So then what is the change in velocity, the magnitude of change in velocity? So that's what they are asking. See, first thing is, so a stone is tied to a string of length L and is really, so fine, this string length is L, so that this also length will become L. At certain instant of time, the stone at its lowest position and has a speed u. So at the lowest position its speed is u. So write down this point. Next, so the what is its velocity first when it reaches the point P? So let this be point P. So find the velocity at point P. So we know that Vp is equals to square root of, so let this point be A. So Va square minus 2gr into 1 minus cos theta. Yes or no? So now, so the Vp is equals to, we are finding the velocity at this point. So square root of, so Va square, so the velocity at A is u, right? So u square minus 2g, so this is L I am writing. So this is L in place of R. So I am writing L. So 1 minus, when it reaches there, so the theta will become 90 degrees. So that this is 1 minus cos 90. Cos 90 is 0. So 1 minus 0, 1. So therefore the velocity at point P is square root of u square minus 2gl. So let this velocity at point P be v. So this is a velocity at v we got. And velocity at A is, see here. So this is velocity at P and velocity at point A is u. So now understand the question properly. This point you can easily solve, right? So it is moved from here to here. So here the velocity is u. So here the velocity is v. We found that velocity. But what they are saying, what is the magnitude of change in velocity as it reaches a position where the string is horizontal? So from here to here, what is the change in velocity? What is the change in velocity? How do you find the change in velocity? See here. So the first thing is, this is the u velocity. Yes or no? So and then here it reached the v velocity. So the change in velocity will be, here the velocity v be upwards obviously. So the change in velocity will be this one. So where the change in velocity delta v is equals to square root of u square plus v square. Yes or no? Here the velocity is horizontal at this point, and at this point the velocity is vertical, right? So that's why, so let me write it in the vector form. U is horizontal, v is vertical. So what is the change in velocity? So the mid, right? So delta V is equals to square root of u square plus v square. So therefore the change in velocity is equals to square root of u square itself. So in place of v square, so shall we write u square minus 2gl in place of v square? V is root of u square minus 2gl. Yes or no? So now v square means root cancels, u square minus 2gl you can write. So that the change in velocity is square root of 2u square minus 2gl. So you can take square root 2 common. So 2 you can take common, u square minus gl, right? So u square minus 2 into u square minus gl. Option 1 is a correct. Clear? Understood, guys? Simple question, just they are changing the question pattern, that's it. But the procedure is going to be same. Basics you have to understand perfectly, that's it. Done, guys? Chal. So now, what is the condition for completing the vertical circle? See here. So the particle will complete the vertical circle, so only and only if string never slacks. Slack means break. So if the string, nowhere the string breaks, see here, this is a circular path, let's suppose. So the particle of bob of mass m, it started from this point. So then at every point the tension the tension should be there. Okay, so now we know that let this point be the lowest point A, horizontal point B, and the topmost point C. We know that the tension at A is greater than tension at B is greater than tension at C. So now we know that the tension at C is going to be the minimum. The tension at C is going to be minimum. So if the particle has to complete the vertical circular motion, the tension at any point should not be equals to 0. So at what point there are chances that the tension may become 0? So at point C, right? Because there the tension is minimum. So there are the chances at point C where the string may slack or break. Yes or no? So when tension will be equals to 0. So that's why the tension is minimum at the topmost point. So if at the topmost point, if the tension is greater than 0, greater than or equals to 0 at topmost point, so other points will automatically will have tension greater than 0. Yes or no? So the condition for completing the vertical circular motion. So the condition for completing vertical circular motion is, so t should be greater than or equals to 0 at what point? At topmost point. At topmost point, so the t should be greater than or equals to 0. So sir, why 0? You are saying it should be greater than 0, right? Why you are saying greater than or equals to 0? Just imagine, so you reeled a object, so which is connected to the string in the vertical circle. Let's suppose, so the mass has come this side. So the mass has come this point. Even if the tension is 0 here, even if the tension becomes 0, so the body will not come to sorry guys, the body will not come to rest immediately. Due to inertia, it will cross this point. Once it crosses this point, so obviously the circle is completed. Understanding? Due to inertia, so the particle will reach this point. Even the tension becomes 0 at the topmost point. So due to that inertia, so it will automatically move further so that it crosses this topmost point. If the tension becomes here 0, it will not reach the C point. Understanding? If the tension becomes 0 at just before the C point, still it can complete the vertical circular motion. That's why I'm saying, so there at the topmost point it can become 0, but before that means, so not just near, so after somewhat far, so it should not be equals to 0. So that means at this point, let's suppose at this point the tension should not be 0. Yes or no? Clear? At topmost point it can be 0. Because of inertia, it can still complete the vertical circular motion. Understanding my point? Clear? Chalo. So now, so at the topmost point, see here. So now let's write the condition. What should be the speed that we should maintain at the topmost point so that we can complete the vertical circular motion. We can do that. See, so the particles, the tension is this side, and then its own weight mg at topmost point will be this side, and so the velocity, so let this velocity at c, so let this point be c, so the mvc square by r. So I can say that mvc square by r is balanced by t plus mg, is balanced by t plus mg, right? So now, so mvc square by r, we have to find what is the velocity at c. So what is the velocity at c, or else the tension should be greater than or equals to 0. So let's write this way, the T is equals to mvc square by r minus mg, right? So here the tension should be greater than or equals to 0 at the topmost point. Yes, so therefore the tension at the topmost point is this one. So therefore mvc square by r minus mg should be greater than or equals to 0. So which is nothing but, so the mvc square by r must be greater than or equals to mg. So from here m cancel, so the vc square should be greater than or equals to g into r. Send this r to that side. So therefore the velocity at c should be greater than or equals to r. So that means the minimum velocity at point c, at the topmost point, to be maintained to complete the vertical circular motion is root gr. So the minimum velocity that the particle should maintain at the topmost point to complete the vertical circular motion is root gr. Understanding, guys? Clear, everyone? This part done. So very important. So at the topmost point, what must be the tension? It should be greater than or equals to 0 to complete the vertical circular motion. And what should be the velocity, minimum velocity at the topmost point? Root gr, where r is the string length. Yes or no? Chalo. So let's move further. So find the question, see here. So find the minimum velocity at the lowest point of the circle, lowest point, so that the completes the circle. Also find the tension at the lowest point. See here. So they are saying that, see, previously we have seen at the topmost point what should be the velocity? So it should be root gr. Now they are saying how much velocity you should give at this point. So what is the velocity at point A you should give, so that the particle completes a vertical circular motion. That means it crosses this point. So this is the point C. Okay. So what I am doing is, let's apply the conservation of energy between point A and point C. So let it be the point A, let it be the point C, because it has to reach from here to here. So I am going to apply the conservation of mechanical energy. So see, the kinetic energy at A plus the potential energy at A is equals to, so the kinetic energy at C plus the potential energy at C, right? So the kinetic energy at A, so the particle's velocity at A is half mva square. So consider this as the ground. So consider this as a ground. So now so the potential energy at the ground is 0. So then at C, so half m, so the velocity at C is vc. So square root of, half m vc square plus, so what is the potential energy at C? Mg into, so the height, how much is the height from here to here? So from here to here it is r, and from here to here it is r again. So therefore 2r, right? So therefore I can write half mva square is equals to half m. We know the velocity at C. What is the minimum velocity at C? Root gr. So root gr whole square, right? Plus this is 2mgr. So now half, here I can write half mva square is equals to half mgr. Sir, half mgr, yes, plus 2mgr. Sorry guys, I am having cough and cold, please don't mind. So here m cancel. Now So VA square is equals to, so 2 you send it to that side, so it becomes 2 if you send it to this side, so this multiplication, so GR plus this is 2GR into 2, so which is 4GR. So then I can write, so the VA square is equals to 5GR. So then the velocity at point A is equals to root 5GR. The velocity at point A is equals to root 5GR. So clear? Understood? So the minimum velocity that you should give at the bottommost point so that it completes a vertical circle is root 5GR. Understanding, guys? These are all the standard results you have to remember. So at the bottommost point, how much velocity we should give? Root 5GR. So in topmost point, what should be the tension? T greater than or equals to 0. What should be the minimum velocity that the particle should maintain to complete the vertical circular motion? Root GR. Done? Clear? Sure. So the NEET 2016 question. So understand the question, guys. What's the question says? So what is the minimum velocity with which a body of mass m must enter a vertical loop of radius r so that it can complete the loop? See here, what is the minimum velocity with a body must enter the loop? So consider this is a circular loop. So here, with what minimum velocity it should enter? So what is the minimum velocity at the bottommost point? It should be root 5GR, root 5GR, root 5GR. Option 2 is a correct one. Direct question. Clear? Chal. So let's move further. So let's go for the next question. See here, guys, the question. What's the question says? If velocity at lowest point is just enough for the looping of the circle, find the velocity and tension when the string is horizontal. See here. If velocity at the lowest point is just enough for the looping. See here. So this is a circular path. So this is a circular path. So if the velocity at the lowest point is just enough for the looping, just enough for the looping means here the velocity is given as root 5GR. Okay. So then for the circle, find the velocity and tension at the string when the string is horizontal. So when it is originally here and then when it moves to this point B. So what is the velocity at this point and what is the tension at this point? So what is the velocity VB and what is the tension at this point they are asking. So the velocity at point A is given. So let this be point A, let this be point B. So and the angle is theta 90 degrees. So let's do one thing. Apply the conservation of mechanical energy. So the kinetic energy at A plus potential energy at A is equals to kinetic energy at B plus potential energy at B. Right? So yes. So then consider this as a ground. So if it is the ground, the potential energy at A is 0. Right? So the kinetic energy at A is half mVA square. So the potential energy 0. So is equals to kinetic energy at B half mB square. mVB square. So the potential energy, so it's going to be, let the radius be r. So here also the radius r. So how much height when it becomes horizontal? mg into h, height is r. Right? So from here I can write half into mass into, so the velocity at point A is root 5GR. So root 5GR whole square. Right? Which is equals to half into mass into VB square which plus mgr plus mgr. So m cancel. So then half into, so 5GR is equals to, so let's write this as half VB square plus GR. Right? So then send this half to that side. So it becomes 5GR. So here VB square plus 2GR. So that the VB square is equals to 5GR minus 2GR, 3GR. So from here the VB is equals to root over 3GR. So the VB is equals to root over 3GR. So the velocity at point B is root 3GR. So root 3GR is there only in the option 2. Is there only in the option 2. So they also asked us to find the tension when it is horizontal. See, how do you find the tension? So when the particle comes to this point, so the tension T will be this side and the centrifugal force half mvb square by r, centrifugal force this side, and then what else is there? Its weight mg downward. So the weight doesn't matter, the tension is simply balanced by, see here, so the tension is balanced by mvb square by r, right? So the tension T is equals to m into what is Vb? So just now we have seen root 3gr whole square by r, right? So square root cancel, T is equals to 3 into m into 3gr by r cancel. So the tension is equals to 3 mg. So the tension is equals to 3 mg, and so the velocity is equals to root 3gr at this point P. And you also find the tension in this case, previous case where, see guys, so at this point, at the top bottommost point, so find the tension. So in the question they said tension also, we just found the VA. So what is the tension now? So let's see the tension here, T upside and mg downside, and what else will be there? The centrifugal force mva square by r, the centrifugal force mva square by r. So therefore T is equals to mg plus mva square by r, right? So T is equals to mg plus the velocity at A we got, which is root 5gr, root 5gr whole square by r. So am I going fast? So just the concept is easy, we are following the procedure, that's why I'm going bit faster. Okay, so mg plus here square root cancel, 5 mgr by r cancel. So 5 mg plus mg, 6 mg is a tension at the top bottommost point. So let me summarize these three questions here. So let me let's summarize here, you'll understand better. See guys, so just what are the results that we have seen? So to complete the vertical circular motion, let's suppose the particle has started from the A point, this is a horizontal point B, and then this is of radius r, and then this is the point C. So first thing is, so at some general point P, if you want to find the velocity, so the general point V, so if you want to find the velocity, it's going to be VA square minus 2gr into 1 minus cos theta. This is a formula, the velocity at some general point P. And so we have also seen the tension at A, we got 6 mg when it completes a vertical circular motion. So the velocity at A, we got root 5gr. This is the minimum velocity to complete the vertical circular motion. So and velocity at B, when it completes the vertical circular motion, is root 3gr. And then the tension at B, we got it as 3 mg, right? And then, so the tension at C must be greater than or equals to 0 to complete the vertical circular motion. And what is the velocity, the minimum velocity at C to complete the vertical circular motion? So it is root gr. It is root gr. So that's it. These are the only things that we solved, that we discussed till now. So this is a summary, whatever we discussed till now. Understood guys? Is the concept clear till here? Everyone. So just have a look at that quickly. So let's see the next question. So the 12th question, what's the question says, see here. As per the given figure, to complete the circular loop, so what should be the radius if the initial height is 5 meters? So they said to complete the vertical circular loop. So to complete the circular loop, they said, so this height is 5 meters. An object is dropped from here. It is dropped, it released from here. So it came here. So here, if it has to complete the vertical circular motion, what should be its velocity here? So here the velocity should be root 5gr. The velocity at that point should be root 5gr, right? So the minimum velocity at point A, or else let's do one thing. So let this be point X, let this be point Y. So apply the conservation of mechanical energy between point X and point Y. So Ux plus Kx is equals to Uy plus Ky. So initially the X point potential energy is there, mgh. So then it is released. So initial velocity is 0. So kinetic energy 0. So here let's consider this as the ground. So the potential energy at y is 0. So the kinetic energy at y is half mv at y whole square, right? So then this is mg. So this height is going to be phi. They gave it in the question, right? Half mass m. So the velocity, what is the velocity? So there it should be root phi g r. Velocity at y. To complete the circular loop means here the minimum velocity at the top, bottommost point should be root phi g r. So in place of vy, I am writing root phi g r whole square. So here square root cancel. So this is and you can cancel m also. m. So phi g is equals to half into what is there inside. So phi g r, right? So then what do we require actually? So we need, what we have to find as per the given question, what should be the radius r we have to find. Any calculation mistake we did? No. ux, initial potential energy is mgh, h is 5 meters, initial kinetic energy 0. So this is uy 0, potential energy, half m vy square. So this is root phi g r. So mg into phi is equals to half into mass into phi g r. Okay, fine. Phi g is equals to half into, so phi g r, right? So this is going to be 10g is equals to phi g r, right? So g cancel. So r is equals to 10 by 5, 2 meters. So the radius r is equals to 2 meters. Option 1 is a correct one. Clear, guys? Sure. Let's move for the next question, which was asked in NEET 2018. So what's the question? Same kind of question, previous one. A body is initially at rest. So here initially it is at rest. So sliding along a frictionless track, a height h. So this height is given as shown in the figure. It just completes a vertical circle. It just completes a vertical circle means at this point, let this be point y, let this be point x. So what is the velocity at y? It just completes a circular motion means the velocity should be minimum velocity root phi gr. So whose diameter AB is phi d. So let this be point A, let this be B. So whose diameter is D. Okay. So again apply the conservation of mechanical energy between point A and point D, point Y, point X and point Y. So ux plus kx is equals to uy plus ky. So initial potential energy is equals to mgh and initial kinetic energy 0. So final potential energy 0 because that's the ground, and final kinetic energy half m vy square, right? So here this is mgh is equals to half m vy is root phi gr whole square. Same concept, square root cancel, here m cancel. So gh is equals to half into phi gr. So from here, so g cancel. So the what we need, the diameter, the height h. So h is equals to, what is this, half phi by 2 into r. So but we need in terms of d. So let's do one thing, h is equals to phi by 2. So this is the radius r. So shall we write diameter by 2? So which is nothing but h is equals to phi d by 4. So h is equals to phi d by 4. Option 4 is the correct one, guys. Clear? Simple thing. Done? Chal. So now see the important concept. So to complete the entire circle, the minimum velocity at the lowest point must be root phi gr. So now what if the velocity is not equals to root phi gr? So what will happen if velocity at lowermost point is less than root phi gr? Will it complete the vertical circular motion or not? So if not, will the string break, or will the string will not break? So what happens? What are the different scenarios if the velocity is less than root phi gr? Okay. So see here. So the first thing is, if the velocity at the lowest point is greater than root 2 gr and less than root phi gr. See here. If the velocity is greater than root 2 gr and then less than root phi gr at this point velocity. So then what happens is it crosses the horizontal point. It crosses the horizontal point, but it unable to reach the topmost point. If the velocity is less than root phi gr and and greater than root 2 gr. Sir, why root 2 gr? It should be root 3 gr, right? Even if you give the root 2 gr, due to inertia it will move further. That's what. Okay, so if it is greater than root 2 gr and less than root 5 gr, so it will cross the horizontal point. It will cross the horizontal point and reaches some point here. So reaches some point between B and C. Let this be point B, let this be point C. So horizontal point and the vertical point. So it reaches somewhere in between. So there the tension will become 0. That means the string slacks. So the string slacks. So the tension in the string becomes 0 before reaching the highest point, and the string slacks. String slacks means string breaks. String breaks, but the particle's velocity will not become 0. The particle velocity will not become 0. So that means, so while coming after coming here, so the string breaks, the particle will go out of the circular motion. So go out of the circular path. Understanding? So the particle will leave the vertical circle. So the particle leaves the vertical circle, so between 90 to 180 degrees. So the important thing that you should understand is, in this particular scenario, the tension will become 0. The string slacks. So but the particle's velocity will not become 0. The particle will leave the circular path. So between 90 degrees to 180 degrees. Clear? So when the velocity is between root 2 gr and root 5 gr. Clear? Understood? Chal. So if the velocity at the lowest point is, so 0 less than or equals to v less than or equals to 2 gr. So it means it is less than or equals to 2 gr. Previously greater than 2 gr, less than root 5 gr. So now if it is between 0 and root 2 gr. So here what happens is, the particle will not reach the horizontal point also. The particle will reach some distance between horizontal point and the bottommost point, and the particle will oscillate. See here. So if I give some velocity to this one, if I give the velocity 0 to root 2 gr, so then what happens? See here. So it just oscillates, and then after some time it comes to rest. See here. So the string will not break. See here. Is the string breaking? The string will not break. After some time it comes to rest. So that means, see here. So what happens? The tension will not become 0 and velocity will become 0. So and particle will not leave the circular path. The particle will not leave the circular path. The particle will oscillate in the lower half. So from here to here, here to here, it oscillates, and then finally it comes to rest. Its velocity will become 0. But previous case, its velocity will not become 0. It leaves the circular path between 90 to 180 degrees. Okay, and then its tension will become 0. That means string breaks. But here the string will not break. Clear? Understood? So velocity becomes 0, but tension is not 0. So theory questions directly they can ask. Then guys, understood? So find the height at which the string becomes slack. So you guys take this question as the homework. So the velocity at the bottommost point, I am giving it as root 3 gl, where so the velocity is less than root 5 gl, right? Obviously the string will break. See, if it is greater than root 2 gl, see here, the velocity here it is less than root 5 gl and greater than root 2 gl, so that the particle, the string slacks. At which point the string will slack? So between the horizontal point and the topmost point, somewhere around here, the string will slack, where the tension will become 0, the velocity will not become 0. So now they are saying at what height this string will slack. At what height means, so this height you have to find. This height you have to find, guys. So what is this height from bottommost point? So this height is how much at which so the string will slack. That's the question. Okay, you take this question as a homework. Okay guys, so with this we have completed the vertical circular motion and the complete circular motion. So next we will start the work, energy, power. So till then, keep studying. All the very best guys. Bye. Take care.